Solutions for the problems. I'm going to do some of them quantitatively with numbers, and then others I'm just going to sketch out. But I'm going to start with numbers, and then we'll do sketches. So we've got a red car starting at 1.2 meters and moving in the negative direction for 6 seconds. So I'm going to draw my axes. Even when you're just sketching, you still want to do a good job. So we've got time and position, and because the red car I'm going to say is moving at 40 centimeters per second, that's how I'm going to label my hash marks. So I've got 1, 2, 3, so that would be 0.4, 0.8, 1.2, and then I'll do negative 0.4, negative 0.8, and then negative 1.2, and then my seconds 1, 2, 3, 4, 5, 6. And I'm just going to label 6 and probably 2 and 4. Okay, so I start at 1.2 at 0 seconds. And then after 1 second, I'm moving in the negative direction. And so I've gone 0.4 meters in the negative direction. After 2 seconds, I've gone another 0.4 meters. At 3 seconds, I'm at 0. At 4 seconds, I'm at negative 0.4. At 5 seconds, I'm at negative 0.8. And at 6 seconds, I'm at negative 1.2. And that's because every single second, the car goes 0.4 meters or 40 centimeters. And so that's what my graph looks like, and so I'm going to go like that. All right. A blue car starting at negative 0.1 meters and moving in the negative direction for 0.6 seconds. All right, this one I was a little bit trickier with because my blue car is moving at 0.2 meters per second. All right, so time in seconds, X in meters, but I'm at 0.1, so I have to pretty much label everything by 0.1s. All right, so negative 0.1, negative 0.3, negative 0.5, negative 0.7. I know right now some of you guys are asking, can you do that? And it's sure. You really can label however it's convenient. I probably don't have enough space. Maybe I'll move up. Okay. And then time 1, 2, 3, 4, 5, 6. So blue car is at negative 0.1 at 0 seconds. And then after 1 second, it's gone 2 centimeters in the negative direction, or 0.2 meter, 20 centimeters or 0.2 meters. After, so this is 1, 2, 3, 4, 5, 6. 2, I've gone to 0.5. 3, I've gone to negative 0.7. 4, I've gone to negative 0.9, and so forth. You can keep drawing if you want to, but that's good enough. All right. A wind-up toy that moves at 0.1 meters per second, starting at 0 and moving in the positive direction for 6 seconds. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So it's starting at 0. So 0.1, 0.2, 0.3, 0.4, 0.5, label. 1, 2, 3, 4, 5, 6. T is 6. So I know that it's starting, green, at 0, 0. After 6 seconds, I know that it's going to be at 0.6. How did I get that? Well, I know that we have this formula. X is equal to the velocity times t plus x0. This is 0. My velocity is 0.1 meters per second, and after 6 seconds, that gives me 0.6 meters. So you just plug it in, and then you can draw a straight line. So that's another way to do it, perfectly fine. Blue car starting at 1 meter, moving in the negative direction for 6 seconds, and a red car that starts at the origin, moving in the positive direction for 6 seconds. I think the direction might have been left out on the original, and if so, I apologize for that. Okay, so we've got position and time, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You usually want to take some time and make these as even as possible. And then 1, 2, 3, 4, 5, 6. All right, blue car starts at 1 meter, and it moves in the negative direction for 6 seconds. Oh, I totally messed this up on my labels. Oops. To relabel them as 0.4, 0.8, 1.2, 1.6, 2.0. Sorry about that. Got excited with the wind-up car. And then minus 0.4, minus 0.8, minus 1.2, minus 1.6, minus 2.0. Okay, so blue car starts at 1, which is going to be here, and moves in the negative direction. So that means at 1 second, it's going to be at 0.8, because 1 minus 0.2 is 0.8, and then 0.6, 0.4, 0.2, 0, negative 0.2. I know my line's kind of curving, and then negative 0.4. So that's approximately the blue car. And then red car starts at the origin and moves in the positive direction for 6 seconds. So there, 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 there. So each second it's moving 0.4. So it looks like that. Cat sitting on a rug. You can kind of play around with this one. The important thing, let's see, what color of cat do we have? Let's do a gray kitty. Gray kitty sitting on a rug. And you can actually put this wherever you want, because I didn't specify. If you want the cat to be the origin, then you could do it like that. Or you could do it up here, or you could do it up here. The important thing is I have a flat line. All right, let's go back and add in velocities. So velocity, oops, and do black. So velocity are super simple. You really only, so meters per second, time in seconds. So we have the red car, 1 hash mark, 0.4, and we draw a straight line. Okay. Blue car, oh, wait a minute, moving in the negative direction. Looks like that. Blue car, moving in the negative direction. Still have to label. Negative 2. Negative 0.2. Okay, wind up toy. .1, positive direction. blue car and red car. So blue car is moving in the negative direction. So I think I'll do a negative 0.2, positive 0.2, positive 0.4. So we've got blue is going negative, so we can call that blue. And then red is positive, red. And then cat sitting on a rug. I'll show you my preferred when you have 0 velocity. I want you to draw it, draw it just above, or you can bold it. And the other thing is, do not go all the way to the end so that I can tell you've actually drawn a line.